So big tech is bloated. Let's talk efficiency. I'm Craig Kronenberger. I'm here with Charlie Wardell, and we're going to talk a little bit about a pretty significant problem that's going on that I think nobody really wants to admit to, and that is most of this infrastructure talk that we hear, in particular around AI, it's really bloated, and teams are burning cash on compute that they don't need. They're locked into these contractual agreements, subscription agreements that they don't use, that they're not getting value from. In many cases, they barely control. You've got issues around security, who can actually see what you're doing on these systems. And so a lot of this becomes a huge problem, I think, in the industry in general. And I think that's a big part of why this company exists today. Is ultimately this is dumb the way this is going. This isn't the right direction. And so, Charlie, you built the company to kind of fix this problem. So let's try to start to unpack this now, learn a little bit more about that and kind of your motivation. So the first thing is, what was the thing that said, okay, this is enough, this is broken, they're not thinking about it the right way? What was that kind of hit you, that realized that this is an opportunity here and you need to change the narrative?
Yeah, I was looking at the developers that work for me, and oftentimes I noticed that they were using the wrong tools for the job. And it was as simple as that. If you only have a hammer, everything seems to look like a nail. And particularly in the area of processing and efficiency, data pipelines and things like that. I would get a developer who would be very happy about a new algorithm that he created, and it's running against the data set, and it's doing its job, and it's working really well. And I would ask a simple question about, well, how many records per second does that process? And it would come up, well, probably about 1,000, 2,000, very confidently.
Yeah.
I'm like, how many records do we have? It was like 100 million. And
right.
Then you see the light bulb go off and saying,
this is going to work.
Is this going to work? Is this going to, what is your answer? Is it to scale it out on massive amounts of a cluster? And being a startup, you just didn't have that type of wherewithal to do that. So there had to be a better way. So there is technology, if you know about it, that can accelerate processing. You just have to think outside the box a little bit and stop, following the trends, so to speak.
How much of this problem is about people aren't aware, or how much of the problem is about they just don't care? Because people are just doing it, they're going through the motion, and no one's caught up on cost yet until it starts to become a problem. Or is it really awareness and they don't know this exists out there and that there are other options to focus them more on trying to be a little bit smarter and a little bit more efficient with their thinking?
I think it started out with people didn't know, and then it turned into people didn't care, because the pressures and demands of getting things done quickly meant that they should be able to take on a project, get it done quickly, it doesn't matter about, we'll optimize later. But it is an optimization that is a Band-Aid until you realize that you can't go that route and you have to go back into caring mode.
Yeah.
Right. So it starts off where they used to care, but technology has moved forward enough to where let it take care of it for me. I don't have to care so much until we realize, oh, I have to care all of a sudden, because the processing's just, the throughput's just not there.
Well, and I'm assuming that we're getting to this point where cost is going to become a problem for many, many of these companies. They're going to run into this barrier around cost itself. And so people are going to have to start to talk about efficiency. It's going to have to become more important. I mean, are you hearing it out there?
Absolutely. The cloud is like Hotel California. You can check in, but you can never leave. It's an absolute amazing thing. If you're not on the cloud while you're a startup, you're stupid. And if you're in the cloud when you're an enterprise, you're stupid.
Yeah.
Right?
Yeah.
I've had a customer who had a mandate to take $1 billion out of their cloud spend.
Right. Yeah.
So it's just absolutely mind blowing as to once you're locked in, you're in, and then untangling the web of dependencies that you've had put in place in order to get your work done starts becoming more and more difficult the longer you stay.
Yeah, to be able to do it. So you see that there's this opportunity to create something that's a little bit more leaner. How did you kind of get to this point where you say, okay, look, this can be something that is a solution and a product that you can kind of bring to the market? I mean, what was that? How did you kind of come to that thinking?
Yeah, that was an epiphany, right? We were doing a work for a fintech company. They were processing 20 years of historical data. They were doing back testing, and what they were doing with the historical data, it was unstructured text, which parsing and tagging is very slow to begin with. But it was 20 years across 30,000 companies. It was a massive problem. So we would crunch these numbers to identify the tags in the text. It would take about a week to run. We had 130 servers running. And at the end of that process, we would hand the results over, and they would do their back testing. And they would see if it moved the needle or not. If it didn't move the needle enough, they would tweak their models and the tags they wanted to find, and we would rerun it for another 7 days on 130 servers. And we just did this cycle over and over again until they got it tuned to where it was performing the way they wanted it to. It was melting their credit cards.
Yeah.
It was absolutely expensive. So they said, you got to help us. Is there a way to optimize and speed this up? Now, I have some history working with Netezza. They had a unique database which was hardware accelerated. And it always struck me as to they were just hardware accelerating a small piece to open up a bottleneck, and it made the performance go a lot faster. And I wondered if I could do the same thing. So I started exploring FPGAs in the process flow, and it was a project where I took on a cluster of FPGA servers. I grokked them to basically do some processing of unstructured data. And it brought the 7 days down to 2 days, and 130 servers down to just 4 servers.
Yeah.
And so now it's an overnight process, and it went from like $16,000 a week of spend to just a few $100. And then I realized at that moment, wow, this is what people are not aware of.
Yep.
This is not new. We know it from back in the day where you only had a CPU and you had a math coprocessor. The math coprocessor would take and do the math so the CPU didn't have to do it. You were offloading the math to a math coprocessor. And then the GPUs came along, right? And you were unloading the graphics processing off of the CPU onto something more efficient. We were doing the same exact thing. We were doing this data processing, and we were offloading the matching and the very sophisticated algorithms to an FPGA. So this coprocessor mentality has been around for years, but nobody really is able to exploit it because they don't know how.
Got it. So okay, so time goes by then, and you start to develop out this thinking, and then you create Cortex-1. So go deeper into what is Cortex-1 and kind of what is it providing.
So think of Cortex-1 as a single interface to a array of different types of technologies. I try to compare it to a printer. We all have a printer driver, and we print to that printer driver, and we can support thousands of printers because the protocol to the printer driver has been standardized and established. What if we had a protocol to Cortex-1 that was standardized and established, and it took care of sending it to a CPU, or sending the payload to a GPU, or sending the payload to an FPGA, or a RISC processor, or an ASIC, or something like that. So completely abstracting out the complexities of the hardware so that you can focus on just calling that one type of API.
So let's look at like the Cortex-1, what it solves now. and then why it's even more beneficial looking out over the next couple years. How is it going to kind of transform as a technology and the value it's going to create?
All right, so looking at Cortex-1 now, you're looking at it as a series of functions as a service. You can call those functions, and you don't have to worry about how that function is operating. Is it running on a CPU? Is it running on a GPU? It's completely immaterial to you. In the future, you'll have a little bit more fine-grained control over the types of where and when that runs, but we're taking care of all of that for you. So we have these functions, think of them as functions as a service, that we will basically seed the marketplace with a whole bunch of them and open up the marketplace to develop them and allow you to basically string your workflows together using these functions. And those functions could be hardware accelerated.
What about as the industry starts to evolve and technology around processing starts to change and evolve in itself? I would assume that this technology is going to be very helpful in because it's going to get more diversified. I mean, right now we're primarily GPUs, CPUs,
right,
predominantly, but the processor market is expanding and it's evolving very quickly. So the need for this technology seems like it's even more important because it's taking all of that out of the process for you. You don't have to think about it. And it's going to get even harder for people because we're going to be introducing different types of processors for different types of needs as the market continues to evolve.
Yeah, so if you take if you only have a hammer, everything looks like a nail. That's the CPU, right? That's a general purpose CPU. And the GPU is starting to challenge that, which is really interesting, and it's opening up a lot of opportunity. But it's also proving an approach, right? Because it's not about the CPU and GPU. We're calling them XPUs. It's anything other than a CPU and GPU. And there's a lot of these things coming out right now. We have inference processing units. We have blockchain processing units. We have crypto processing units. We have all of these XPUs that are starting to come to the market because the difference in processing a payload that needs crypto on a CPU versus a KPU is radically different in performance. It's not even, you can't even compare them. It's like saying, sure, I can do that image enhancement on a CPU, but a GPU does it so much better and so much faster. Just because you can on a CPU doesn't mean you should, right? There are tools out there that that you have available to you that you can exploit and really hyperscale the processing that you need. The average developer doesn't know they're out there, and they don't have access to them because the cloud doesn't provide them.
Yeah.
The cloud's providing CPUs and GPUs, and that's it.
So okay, so let's talk about the data center model. You know, if you look at the media, if you're an investor out there, you're certainly getting very exposed to this. It's about bigger, 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 more. It's about this massive investment into larger data centers equipped with better, faster processors. And there's this cycle that's happening. And in many cases, it's a race, and there's more and more of it that's actually occurring. And then if you look at these data centers, their business model, obviously they're cutting contractual agreements with companies, corporations, to essentially help finance and support the development of these data centers themselves. Therefore, then they're cutting deals with hardware, software providers that are helping to support these data centers. The whole thing with the model itself, it just seems like it's big, and I start to question it because it seems like a lot of the hardware that's being purchased, the life cycle of it is very short. It doesn't last long, and these data centers getting enough value out of it seems problematic, and it's always this race to get the next big thing. And so I just question, is that necessary? Does that business model even work? Is it the right business model to even be thinking about it? And it seems like it's off. It seems like it's all about big, more.
It's the economy of that big. It's opening up an economy around it, because everything around that big and more is forcing a change in the way you think about software development. Everything is changing, from the way you host those servers, the way you connect them to one another, the switches that support them, the power that's required, the space that's required, the cooling that's required. Everything is radically different than what it was just a few years ago. So that is opening up a tremendous market of all of these other economies, right? And one of the things, so that model is here to stay, right? That ship is sailing. The question is, when these devices, it's moving so fast that these devices are becoming end of life very quickly. And if you're have the everything looks like a nail mentality, you're going to get bit by that. But if you're using the right tool for the job, you could sustain the changes and the ebbs and flow of technology. So that's the point, is to try to find the technology that fits the purpose and get it to where it's processing efficiently. It is radically faster than if you were using it on CPU alone, and basically leave it alone. Let it stay that way. And as technology matures, you'll just benefit by it.
Do you think that from what you're hearing in the marketplace, do you think that a lot of companies are still stuck on this idea of more, bigger is better, plays better to the investor community? Or do you think they're starting to shift towards this model, this thinking of efficiency? I need to be smarter. I need to look at my costs.
Yeah, so the consumer, the end user, the enterprise, they're starting to say, oh boy, right? Because at $2 per GPU hour, and the realization that everything now requires a GPU, development requires a GPU, processing requires a GPU, they're starting to realize that there has been a leap, and yes, a leap in productivity, but also a leap in cost. And they're going to start reckoning with that cost very soon, and they're starting to do it now. But there's also other drivers. It's about, wow, I want to create a language model of my own, and I want to host it, but that language model represents all the secret sauce of my business, right? Am I going to put that out on the cloud, or am I going to enforce a private AI strategy where it is basically on-prem? So there may be, and you may be seeing very soon, a cloud repatriation to some extent, where folks that have taken on the cloud and bought into it hook, line, and sinker are now saying, well, now we have a reason to undo some of that.
Yeah.
Right? Because we don't know the implications of putting our entire business in a single file and hosting it on the cloud somewhere. And you can tell me it's secure, and you can tell me that you have all of the security protocols and firewalls and everything and VPNs surrounding it, but we see breaches every day.
Yeah.
Right. So they may want that tighter control for that type of work to be on-prem. So when you go back to on-prem, now you open yourself up to, wow, I'm not constrained to just CPUs and GPUs anymore.
Yep.
Right? I can use the right tool for the right job. So we're starting to see some of that.
Okay, so let's go to, and obviously the company's focused on the enterprise side, so you can provide solutions at the enterprise level, so you can help them solve that part of that problem for them, correct, with the technology? Yeah.
Right.
Let's now take it and flip it, go back to, let's say you're an individual developer, you're based in India or maybe Brazil. Let's talk about some of the challenges that they face as a developer in, as it relates to access to processing and also security as well. what are the things that they're faced with, and also the contracts that they might have to get involved in paying for processing. What are the issues that they run into?
Yeah, so we've seen wait lists for developers to get access to the GPUs that they need to process some big payloads and things like that. But as I step back and I look at it from a higher elevation, I think that the developers are faced with an uphill battle. AI has definitely opened up the eyes in the industry to say, oh my gosh, are we vulnerable? Are we at stake? Are we going to lose our jobs to AI? And if you've had any chance to work with a developer who is using AI, they will tell you that it is just mind-blowing the amount of work AI can do for you as a coder or a pair developer. So it's not the developer who is at risk against AI, it's the developers who are at risk that don't embrace AI, right? So now what we need to do is we need to cultivate a community of developers who are not only embracing AI, but they are able to create their own marketplace for it, because the organizations are not going to need as many developers as they once thought they did, because AI is so efficient, right? So we need to give a place for developers to promote their wares and their IP, and have a method so that they don't have wait lists and they don't have to worry about all of the back-end processing in the cloud infrastructure. They can do their job, they can code, they can come up with IP with or without AI and have a place to put it.
So that's a good point. One is this will help cut through the wait list and getting access. So that's one. And then two is you're not going to have to worry about it. Essentially, the Cortex-1 technology ultimately will help you figure out the best way to ultimately process it for you.
Right.
What about costs? What are developers faced with from a cost perspective? Where are you going to help to try to solve it to make it a little bit easier for them?
So the cost for any function as a service is a consumption model. But what we're doing that's different is that we're trying to be the app store for functions as a service and give the developers an opportunity to mark up their functions as a service and make a profit on each API call to their function. So a marketplace of all these functions, you can browse through them, and me as a consumer can sign up and say I want to use that function. Same interface to use that function. The cost for the infrastructure in the cloud is all baked in, and everything on top of that is the developers.
I mean, are you locking in contractual agreements with them? Is it a pay-for-use model? What's ultimately the model for developers?
For the consumer or for the developer?
For the developer.
Yeah. So for the developer, I like to think of it as free range to go create IP and host your and put a price tag on what it costs to make an API call to that.
Yeah.
So you develop some function.
You define it. Yeah.
Yeah. You define a function that, I don't know, does some very sophisticated math and is able to come up with a data point that could be used in trading, for
Yep.
example. So you develop that, you post it, and you say, every call to this, I want to charge this amount of money.
Yep.
Now, we work on the agreements with the enterprise that will ultimately wind up using it, and try to make sure that they have access to all of those really trending functions. So
then the consumer, is it a pay for use then for the consumer?
Pay for use for the consumer,
okay.
Yes.
So it's pay for use then. If I'm leading an engineer team right now and I wanted to, cut waste and figure out this efficiency, what's kind of my starting point? How would you tell them to think about it, and how does your company and the technology come into play to help better support them?
Yeah, again, right tool for the job. I'll go back to content tagging because I know it so well. We have seen LLMs do content tagging. I can send it a paragraph and I can ask it, what does this paragraph include as far as topics? And it does a great job. It can tell me things like sentiment. It can identify, places and things, and it's fantastic. But we know two things. First of all, for me to send that paragraph and get a response back it's seconds. It's not, microseconds, it's seconds. And second thing is that it's using tokens, so they're pretty expensive. They're not cheap. So the question is the size of your data set. If you're doing batch processing with millions and millions of records, which is typically my background, doing data processing of big data, you could never, ever, for each record make a LLM call. It would break the bank. So you're forced to think outside the box and focus on efficiency. So the question is, I know how easy it is to use LLMs to do certain tasks, but just because you can doesn't mean you should, right? So they have to start unthinking some of this LLM trendy stuff, which is very trendy right now, and very efficient for a coding perspective. I can get it to market very quickly, but efficiency-wise, it's not there, and it's not going to be there for a while. So you're going to have to figure out some old school thinking.
Yep. Got it. Okay. So I think on closing this out, Charlie, obviously I think we talked about it, if you're, tired of kind of these contractual obligations or bloated bills, or you're seeing waste, or if you're not getting the kind of efficiency or even more importantly, the effectiveness out of it, what you're building is obviously a solution for that. So if you could have like a message to every team out there at the enterprise level that's been told, okay, this is how it works, what would you tell them differently? You said before you have to start to think differently about it. What would you say to them?
Yeah, we're seeing a rise of agentic programming. And agentic programming is the stringing together of process flows that talk to autonomous agents, right? But assisting those autonomous agents are traditional functions, because you're going to need some performance characteristics in your process flows. These agentic systems can become very, very complex. Wouldn't it be nice to have an ecosystem that auto scales for you, where you can host your IP, where you can monetize your IP, where you don't have to worry about that availability of LLMs or the infrastructure that's supporting it, and you don't have to worry about performance. And as we start moving our technology forward and using the right tool for the right job into ASIC processors and FPGAs and IPUs and things like that, you automatically benefit by them, right? So
Yeah,
that's the vision.
Okay, I want to go on one more thing here. What is your thinking around security? You talked about the problem that we're faced, this kind of unknown. In some cases, it's almost as if in some cases I've seen where we don't care anymore. We just take the risk and gamble. What do you think is the perspective on security right now, and how do you think you're going to be able to better support it and help solve that problem?
Yeah, so there's more to security of data than what we would traditionally think about as security. There's also a level of compliance. And there are 6 states that have enacted laws to protect consumer data. And there are 14 pending a date, and all the other states are in legislation. So we don't know what that means with regard to language models. If I use data and I use customer data to train my language model.
Yeah, yep.
Okay, And all of a sudden, they have the right to be forgotten because they're in a right to be forgotten state. How do I untrain my language model? Do I have to rebuild it? Do I have to take it off? You know, what is the mechanism by untraining a language model for that particular customer, right? So that's a level of compliance and governance that falls into the realm of security and secure data as well. But what we're doing is we're looking at this processor called a KPU. And this processor allows you to encrypt your algorithm and your data, send it encrypted to a machine with this KPU processor on it. It operates on the encrypted data and the encrypted algorithm, so you can never peek in and see the registers or memory. It's never vulnerable. And then it returns the results encrypted.
Yeah.
And then the person who started it has the key to unencrypt it.
Yeah.
That is just an absolute game changer for security.
Yeah.
And it requires hardware because this type of operating on encrypted data is very time consuming. So you need processors to speed that up. And it will open up the doors to absolute incredible markets where security is, it doesn't matter if your language model is out there.
Yeah.
Right? It can open up to government work and top secret work and things like that. That's the level of security. That
So
we're
will
talking
you
about.
offer the security both at the enterprise level and for the marketplace? So if you're the individual developer in India, will they be able to leverage the same encrypted technology?
Yeah.
Yeah. Okay, that's phenomenal. Yeah.
Yeah.
That's fantastic. Like I said, I think this is a huge problem. I think a lot of developers are already putting their code out there, and I think it's being seen, it's being taken. I think there's a major security problem. I think it's a lot bigger than what we think. So I love hearing the solution for it. That's fantastic. All right. So I think that finishes up. Big tech is bloated. There's a move towards efficiency. We think this is a start with it. Thank you, Charlie. Appreciate it. This is phenomenal, and we're really excited to see everything launch and the marketplace. Excited to see this new security and how you're going to address that. And I love the enterprise offering, and I love this idea of getting people to think differently about it, and kind of how they approach it.
Yeah.
So, thanks.
Thank you.
Thank you.